So good morning and welcome everybody to our exhibitors forum here in Hall 3. I am happy to announce our next speaker, Terry London from Proxpert, who will be talking about preparing industrial device manufacturers for the upcoming EU CRA. Welcome.
Okay, hello. Nice to see some familiar faces already here. So I expect that most of you are coming from industrial automation world and already know something about what Cyber Resilience Act is. And I'm here basically to give you an overview what we are doing with our clients to help them preparing for the Act requirements. My name is Terry London. I'm a tinkerer. I like build stuff from electronic components on my free time, and I'm a product manager of device security solutions. I'm also a partner of the company, and I have been with ProExpert more than 16 years. It makes half of its entire company lifetime. So, if you find it interesting and want to discuss more on the topic, you are welcome to our booth. We are here as always, quite nearby, close to the big semiconductor manufacturers, and we have lots of interesting things to show you about device connectivity and device security. A little bit about us and how exactly we are related to the topic. We have been around more than 30 years, and since the beginning of the company, we have developed specialized software that takes care either remote connectivity of the devices or protects data those devices process during the operation. Back at the early 90s, we started with Applicon bioreactor software development, and that experience led us very quickly to industrial automation world. And last 20 years, we have been integral part of Danfoss frequency converter software development. And at the same time, on the other side, we developed ATM software that used smart cards. And basically from there comes our foundation of device security and secure data transaction experience. And what we are doing now, we are combining those two experiences to help device manufacturers to build more secure products, basically. So we are a software development company. Our main focus is serving industrial device manufacturers. And typically we work like that. Our clients are experts in developing their hardware and the software inside, and those devices are mostly the ones that has to work autonomously months or years without much attention. They have to be very stable. But our role there is to support them on the fields that are a bit outside of their core expertise. For example, device security, internet and cloud connectivity, and digital user interfaces. All those fields are very IT-oriented. We are an IT company, and those technologies and requirements may change a bit too fast to keep up if you are focused on hardware and electronics design and manufacturing. So we are there to support them. And of course, all those new acts like European Union Cyber Resilience Act play its role here as well. We have seen it's been quite tough for companies for last 2 years to figure out what are the next steps, how to start preparing for the act and what it is exactly. So there has been lots of confusion. Basically, we started seeing out right after it was announced autumn 2022. But Cyber Resilience Act purpose is simple. it is meant to unify cybersecurity rules for more secure hardware products, basically, and software products, and across European Union market. There are basically, we can say that all products that are somehow connected or connectable to internet are covered, with some exceptions like automotive and medical devices. And also, luckily, open source solutions are excluded, and software as a service. So, Cyber Resilience Act was to achieve basically two main things, if we simplify. It wants to protect the users of the devices, and it wants to put much more responsibility on the device and software developers and manufacturers who want to sell their products on the European Union market. And why? Because cyber threats are happening. The number of cyber attacks against companies are growing 10-15% a year. They are creating actual damage. The worldwide cost of such damages are estimated around $8 trillion worldwide. And yes, some has to do something. Anyway, we have seen that quite a lot industrial device manufacturers are still thinking that cyber threats don't affect the industrial automation world. Typically, excuse is that those shop floor environments are disconnected for internet or some other way offline. But when we look at the history, we see that it doesn't protect us, and being offline doesn't protect you from a person with a laptop, USB stick, if it goes into the facility, or mobile internet. We have seen ourselves that basically maintenance guys who have to update software for the electronics manufacturing facility, they don't have time to wait 1 hour to get special access from internet, and they use their own mobile phone to activate hotspot and download the software. It basically creates portal to this factory, and it may be enough to create lots of damage if things are unlucky. But anyway, I think actual big issues are coming from the devices connected to internet, because those manufacturing companies are competing, and they are increasingly implementing more and more digital systems and connectivity, because they want to achieve efficiency and productivity. And with such systems, we just have to figure out how to mitigate the cyber risks that come along with the connectivity. But back to the Cyber Resilience Act. The act boils down to 4 simple major requirements, actually. Companies basically must start their products assessed or certified. This requirement has transition time 3 years. The Cyber Resilience Act itself will be adopted probably this autumn. It was already, previously it was planned to be adopted already in this spring, in the beginning of April, but it was postponed till the autumn. So we expect that it will be ready in the autumn. And from that date, the 3-year transition time starts. The second requirement is that companies must start compiling software bill of materials for their software. And third, they must start reporting vulnerabilities found from their software. The vulnerability reporting has transition time of 2 years. So after 2 years, companies have obligation to report vulnerabilities. And last, companies must start providing security updates to basically fix their vulnerabilities. But I will go through each topic quite soon. First, I remind you, the Cyber Resilience Act is actually umbrella act. It doesn't specify the exact technical standards your product has to comply with. You have to understand that by yourself. But you get the idea that here, that depending on the tasks, what your product is basically doing, and the criticality, those products are divided into roughly into 3 categories. It is a little bit more complex, but you get the idea. We can say that smart home devices and connected toys belong to the first, the lowest category, and that require only self-assessment. And more critical products require certification if they are very security related, or third-party assessment. But how to say, everything starts with a self-assessment anyway. So, what is the software bill of material? Sorry. Next 3 requirements. Compiling software bill of materials means that you have to understand what are the components inside your software, who is responsible of each component, how they provide updates, and so on. Basically, you have to have full list. Second, reporting vulnerabilities. You have to have mechanism how do you monitor those vulnerabilities. And this is not yet decided yet, how exactly the reporting process is going to be. Is it some there are arguments, is it some central way, or are there distributed regions where do you report found vulnerabilities? Basically, the obligation exists, but the exact mechanism is not decided yet. And about security updates, this responsibility comes with a requirement to decide your product lifetime. Basically, it is not yet decided if it's going to be 5 years or up to 10 years. Probably it is going to be like that. If you release a product, you decide that, okay, my product expected lifetime is 10 years, and then you are required to support these updates to 10 years. What happens after that, this is not yet clear again. And those security updates must be provided without significant delay and free of charge, of course. The software bill of materials, also called SBOM, is, I think it's one crucial element in Cyber Resilience Act requirements, at least from software development point of view. What does it mean? On a very simplified level, it's a list of ingredients that describes the components in software application. And by definition, it's a list of all open source components, all the third-party components that exist in your system's code. SBOM shows your component versions, if those are components are up to date. Also, it shows all related licenses, and that basically enables us very quick identification if the product has security or license risks. And as you see, SBOM management And vulnerability reporting is basically the same thing. One depends on another. SBOM is typically created and maintained by manufacturer or the supplier of the device software. And if we go a little bit deeper from here, depending on the project type, it can be done in different way. In embedded software projects, the software bill of materials is compiled through the basically by release management, and it is part of the release notes. But if we are looking at continuous integration software projects like most of web developments are today, basically SBOM is a live system that shows your product status in real time. So, and it is a professional software development we are talking about here. Even if the software dependencies themselves don't change, even if we think our software is frozen, basically, we can say that vulnerabilities can change quite frequently because those attack methods are evolving. And as software ages, more exploitable risks are quite likely to be found in the code. And that means we must use proper software tools and implement quite a strict processes to be able to keep our, vulnerabilities visible or to find them faster. And this is nothing unusual for software companies, but it may get a little bit overwhelming, we have seen, for companies whose main job is not developing software. Who are not so experienced, because implementing such processes and tools, to be honest, they take a lot of time. It sounds easy, but it may take even years to get used to those processes. And that's why we are here, actually. Now, to the distributing software updates securely. Traditionally, industrial devices are not so protected by software measures, or even we can say some of them are not protected at all, because most of the time internal processes have worked quite well. But if we are talking about devices that are in physically isolated area, we can say that protection with user password may sound good enough, and it works most of the time, but we already see that big companies are moving away from that kind of practice. So, because more and more industrial devices are connected to internet or connected some kind of secure gateway, and there are two main cybersecurity measures used to protect devices against malicious software updates. One is by creating secure channel between the device and server that distributes the updates. This means that the device and server has to trust each other, create trusted channel, and basically software or data packages are delivered over encrypted channel. This doesn't protect the device itself if it's when it's basically offline. So the second method helps to protect offline devices as well. Basically, we use device-level cryptography here. Device has software manufacturer's public key. Manufacturer has its private key. So some software package is signed with private key, and device verifies if the data package is coming from authorized source. And actually, if we combine those two methods, we can say that today this is a good enough level of security, and it protects devices against malicious software updates. But there is actually a third option as well. It is debatable yet what are the exact application of these methods for industrial automation world. But we call it as device level identity. Basically, each device gets its own identity. We use crypto chips or secure elements and secure MCUs to make each device unique. This is something like Estonian ID card. So the technology itself has been tested long ago, more than 15 years. Basically, we do everything with our ID card. We pay taxes, do bank transactions, we marry, we buy real estate, and so on. So technology itself is proven and worked. And we are looking how to bring such technology to industrial automation world. There are, of course, costs, because more secure boot and data decryption, it costs resources. It costs memory of the microcontroller, it costs computing power and energy. But the benefits here are that device manufacturer actually gets full control over its device. Basically, it can enable that you can license each device separately, because you can decide what firmware package, what configuration is meant for what devices. But such approach requires quite a specific IT infrastructure as well. Basically, quite a complex device identity management system that involves public key infrastructure and complex distributing method. I can show that part in our booth, though I don't cover it. I don't cover it here. But in very short, basically, we are using newest microcontrollers and secure elements to build a solution where all those secret transactions are done in a secure area, so that no third-party application cannot basically peek at those. So back to about how we help our clients to prepare for the Cyber Resilience Act. I repeat it again. It is not so complex as it seems. Even if the Cyber Resilience Act announcement started with quite a confusion, there are 3 relatively simple steps what you can do for your company, and what we are doing. And this is our everyday job. We are still software developers, and we are doing everything here aside or part of our everyday work. Basically, we help companies with self-assessment. Our focus is on ISC 62443 framework. It is a set of standards of cybersecurity for the industrial automation and control systems. And in this topic, as the standard is quite extensive, our focus is on devices, basically. Everything that happens inside the device and everything that is related to the software development process is for that device. We don't cover system level, so we have our focus. What we do, we identify and map product development processes, vulnerabilities. We also suggest security measures to mitigate the security risks found in software code. And I must say, it is always up to our client to decide how to act. Because, as I said, everything has a price. Security has a price. So, and we this is cannot be done independently. You cannot be you cannot sit somewhere else and do this analysis. This is always done together with device development teams. So it is very integrated work actually. So about the SBOM and vulnerability reporting. Basically, what we do there, we set up and manage a software development toolset that supports and helps to monitor the vulnerabilities in our client project. This is again our daily practice and work processes, and on software development side, we focus on the visibility of the software components and how to deliver the fixes, the software fixes as fast as possible. So, what exact tools should we use? This is again an open topic. It depends on the project type and so on. But if let's say GitHub and other environments are already providing the solutions for that. But in many cases, we have to put together the processes and toolsets by scratch. So, because there is no one-size-fits-all solution. And third, of course, we help to implement security update mechanism. And again, this part is dependent on our client business and devices. And it may vary from very simple firmware update to quite a complex infrastructure to deliver those signed and encrypted data packages. In addition, I suggest that companies would put a long-term plan how they are going to maintain all those supporting IT systems. If they want to implement IT team inside the company, it can be quite burdening, or if they want to use outside vendor who takes care of all those updates and technology and requirement changes and helps manufacturer to focus on their core business. So it is important to distinguish that part. So this Cyber Resilient Act is an umbrella act. It boils down to those relatively simple focus points, and if you are doing something here, if clearing basically your home, working on those processes, you have enough time, 2 or something years to basically prepare for it. And if you want to discuss to me or to our engineers face to face, again, this is our location here. We have other security-related solutions here. We can show you how do we integrate devices to the cloud, how do we do factory key injection solutions, and how do we create device identity management systems, and of course secure firmware update solutions. So, thank you.